right, let's talk about similar polygons. So we established ratios and proportions in the last video. Now we're talking about similar polygons, okay? So basically, just same shape, different size. So we use ratios and proportions a lot. There's a big picture of me just right now. I took a picture. This is what we're talking about. Just same picture, small, big, small, big, small, big. That's it. So my face didn't stretch when I made it bigger or smaller. It was just the same picture enlarged or shrunk, right? So you just hold two fingers on your screen and go whoop, 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 whoop. That's ratios and proportions. We're enlarging it, but it's staying the same shape. It's the same face. It's not all tweaked, okay? That's it. That's it, right? So the definition of similar figures is two figures where all the angles are the same, okay? So two shapes are similar if and only if. A good definition is biconditional, right? That's what if and only if means. You can go forwards or backwards. So write that in here just so we all know. So that's the biconditional, if and only if. Right? So we have all the angles are exactly the same. Angles don't proportionally grow or shrink. A triangle is always 180 degrees, no matter how large the triangle is or how small. Okay? But the corresponding sides, instead of being congruent, are proportional. Okay? So here's what I mean. Right? Are all the angles the same? Yeah. One angle to one angle. Two angle to two angle. Three angle to three angle. Yes. All three angles are the same. Exactly the same. Congruent. But the sides, we're looking for proportionality. Remember, proportional means two equal ratios. Ratio equals ratio. That's what a proportion is. So what we mean is, do all three sides have the same ratio? So we take the smallest side to the smallest. And then we compare the medium to the medium and the big to the big. Right? That's it. So we don't do any like, well, the 7 looks like it goes with a 7. You'll get tricked that way. It's biggest side corresponds with biggest side. That's how you know which ones to set in a ratio, and we'll do problems like this down below. Okay, and so notice I did 5:50 equals question mark, like are they equal 3/30, and is that equal to 7/70? And then what we do is we simplify each ratio, or just plug it into a calculator. We would get 0.1, 0.1, and 0.1. Yes! All those ratios are the same. That means the sides are proportional. Okay, so all the angles are the same and the sides are proportional, shapes are similar. And then we have a symbol that shows they're similar. It's this wavy line. Triangle ABC is similar, that wavy sign similar to triangle DF. Now notice, these are similar, but they're not the same size. If they're similar and equal in size, they're congruent. That's what it means. Equal number, algebra, equal size number, right? 5 equals 5, same size. And then this is the shape. So same shape, equal size, that's what congruent means. What? Just shattered. It all makes sense. Okay, anyways, order matters in similarity. So if we say triangle ABC is similar to triangle DF, just like with CPCTC, I know that A and D correspond, so those angles are congruent. B and E correspond, those angles are congruent. C and F. Remember, all angles, well, corresponding angles are congruent, okay? Then the sides are proportional, so that means the ratio of corresponding sides are the same. So AB divided by DE, that ratio, whatever that ratio is, has to be the same as BC divided by EF, which is also the same as A to C divided by D to F, right? Those are the ratios, and they have to be the same. That's what proportional means, is the three ratios that the three sides make are equal. And that number that they're equal to, we call the scale factor, or we call it a similarity ratio. It depends on like the book or IXL, but either scale factor or similarity ratio, it's that common ratio between all the corresponding sides, right? So up here, when all of these were the same, that was the scale factor, the number they were equal to. Or up here in this example, the scale factor was 1 to 10, or 0.10. And of course, you could do forwards or backwards. So notice down here, the very first question on the homework is, which one of these kids are right? Okay. They've got two similar triangles. It's given that they're similar. That's just part of the question up here. But then it says which one's right. So this one does AB to PQ. So he does 8 to 10, and he gets the smaller number on top, 4 to 5. Whereas the other person does the other order. They go PQ to AB, And that's 10 to 8 is 5/4. Those are the same scale factor. They're both right. So it's kind of a trick question. It's like, who is correct? They're both correct. They're just looking at it from different sides. One is saying from here to here, it's a 4 to 5 ratio. And the other one's saying from here to here, it's a 5 to 4 ratio. It doesn't matter which one. The only time it matters is if the question specifically says, what is the ratio of this one first to this one second? If they tell you the order, then the order matters. Otherwise, if they just say, what is the scale factor, it doesn't matter. You could say this one to this one or this one to this one. So 2 to 1 and 1 to 2, you're just starting at a different triangle and going the other way. But the ratio is 1 to 2 or 2 to 1. They're both a valid ratio. That's totally okay. All right, so here it tells us in this figure, lists all pairs of, so using similarity. See right here, it says these two figures are similar. So what that means is D is the same as P, right? I'm not even going to use the picture. I'm just going to do it from the letters. I know this means angle D is congruent, exactly the same as P. Angle E, angle F in order, angle G, those are all exactly congruent to, in order, angle Q, angle R, and angle S. Now, what do we do with the sides? Remember, we don't know the sides are equal. All we know is whatever ratio they are is the same. So let's see, the first side is DE is 2, and then that's going to be, and I'm just going to go clockwise around here in alphabetical, so from E to F, and then from F to G, and then from G to D. Okay, and those correspond with, again, I just go in order, right? So I went from D to E to F to G, and then I always loop back because it's a closed circuit to make a polygon. So yeah, I'm going to go from P to Q. And I could just mark this on the diagram if that's helpful, right? So I'm going to just number these. Here's angle 1, 2, 3, 4. And then here's the exact same angles in the other picture. So starting at P and then going to Q. 1, 2, R is 3, this is 4. So between 1 and 2, DE is between 1 and 2, PQ, right? And then after PQ, it's QR. And then after QR, it's RS. And then the last one, S back to P, is the same as G back to D, right? So those four are all the same. Again, we don't know what the scale factor is. Okay, all right. So there's all of it. That's a statement of proportionality. There's the 4 congruent angles. There's the 4 sets of sides are proportional. Find a counterexample to all rectangles are similar. Oh, okay, for 2, that's an easy one. Okay, so here's a rectangle that's 1 by 2, right? We know the opposite sides of rectangles are the same, so that means this is a 2 and this is a 1, right? Is that similar to a 1 by 3? No. Now we know all the angles are the same. For it to be a rectangle, it's got 4 right angles. So we can't break the angle relationship. However, we can break the ratio because, again, if we set this up to test all the sides, and again, opposite sides are the same. So we would go small side of, let's do the 1 by 2 on top, just for clarity, and then the 1 by 3 on bottom. So I would go small side is to small side as small side is to small side as big side is to big side as big side is to big side. So this would be checking proportionality. Here are the 4 sides of the 1 by 2. Here are the 4 sides of the 1 by 3. They're all lined up with their matching smallest, smallest, medium, or large, you know. And no, these aren't the same, right? This is 1 equals 1 equals 2/3 equals 2/3. Those are not all in the same ratio, so these are not similar. Kind of looks like a fancy X there. Okay, 3, explain whether 2 polygons that are congruent are also similar. So if they're congruent, that means that all the angles are the same. What's the ratio between all the sides? So for example, if I take these 2 triangles that are congruent, 1, 2, 3, all the sides are, all the angles are congruent, of course. So angles congruent by CPCTC, okay? Well, are the sides all in the same ratio? Are they proportional? Well, let's see. I don't know. Let's just make up letters, A, B, yada, yada. Well, what's the ratio of AB to, in the other triangle, DE? What's that ratio if they're congruent? It's 1 to 1. And then the next set of sides, the ratio is 1 to 1 because they're equal, right? So whatever, so this would be BC, AC, this would be EF. This would be DF. Well, the ratio, because they're congruent, the ratio is just 1 equals 1 equals 1. So yeah, all the sides are proportional. Not only are they proportional, they're in a ratio of 1 to 1 because they're congruent. So yes, always. And scale factor is 1. That's all that's special. If the scale factor is anything else like 1.5, 1.1, then they're just similar. But if the scale factor is exactly 1 to 1, then not only are they the same shape, but they're also exactly the same size. Okay, this one says, determine whether the pair of figures is similar. Well, like if you just looked at this, you're like, not enough information, done, I quit. But that's not enough, right? We got to really look at it. What do we know here? Well, we know a triangle sums to 180. So we could go, hey, I know this other angle here is 180 minus. And then I go, oh, and the other one too, 180 minus. Hey. 60, 60, 60. What do we remember? That's equiangular. That's equilateral. So that tells me that all the sides are the same. So these are all 7. And then over here, all these sides are all the same. These sides are all 3. Are those proportional? Let's check. Okay, ready? All angles congruent? Check. Right? All the angles are 60 in both triangles. So all the angles match. Great. Are all the sides matching? Let's check. So smallest side to smallest equals medium side to medium equals largest to largest. And oh my gosh, all 3 ratios are the same. So yes, similar. Now, it's hard. So they didn't ask us to write a similarity statement here. There'd be anything because it's got that symmetry since they're all the sides are proportional to all the sides. Actually, there'd be like many possibilities. So QQR would be similar to triangle, and then you could put the other 3 in any order because it's got that symmetry no matter which way you face it, because all the angles are 60, all the sides are 7, so you could put any order for the last one because they're equilateral. Okay, let's look at the other one. All right, so the other one's got, okay, we have 4 matching angles with 4 matching angles. Now let's check if the sides in order match, okay? So let's start with the 1 to 2 to 1 to 2 like this, and we'll go the 1 to 2 to 1 to 2 like this in terms of angles, okay? So I'll just write it right here. I'll write in green. So all corresponding angles congruent. Check, that worked, okay? We see it all, right? The 1 arc, the 2 arc, they do match. Now we got to check is 3 to 9 over 2. Is that ratio the same as 4 to 6? And that's the same as 3 to 9 over 2. And the same as 4 is to 6. All of my ratios went from this triangle to this triangle. And I went in order between the 1 and the 2 here to there, and then the next, and the next, and the next. So this is redundant, right? These last 2 are just the same as the first 2. So really all we got to check is, are these 2 equal? Okay, so I'm going to do 3 divided by 9/2 off to the side. So 3 divided by 9/2. That's the same as 3 times 2/9. That's how you divide fractions. So that's 3 over 1. So multiplying, that's 6/9. That's 2/3. Okay, so here we have 2/3 equals, and if we reduce 4/6, we get 2/3, and holy moly, check. All the sides are proportional, so yes, there we go. So all the corresponding angles were congruent, all the sides were proportional, yes. So that would be your justify, showing the work that you did it, okay? And then you should write a congruent statement, but again, you have that, you have 2 options. So if you do A, B, C, D is not congruent, is similar to. Now notice, I'm going to clean up this picture just a little bit here. Notice that this 3, 4 across the 1 and the 2 arc is the same as the 3, 4 down here. So actually this would be similar to EFG starting there and going around, or starting at GH. So I'm going to go EFGH. Why did I put a triangle symbol? That was silly. Let's get rid of that triangle symbol there. Okay. But you also could have said ABCD is similar to, and we could have started at G because that was the exact same corresponding angles and everything. So GHEF, both of those statements are true. And then over on the right, we could have done all 3 orders, like jumble those up. So there was actually 3 possible statements there with the orders jumbled. Okay. Each pair of polygons is similar. Oh, they're telling us it is similar. That's useful. And then saying, write a similarity statement and find x. Well, let's look. Okay, so they gave us all the angles. So we know which ones correspond with which. So we know these correspond. We know the hypotenuse corresponds, and we know the 27 and the 18 correspond. So if we were to set this up, it says write a similarity statement. Oh, so first, before you can do that, let's write the similarity statement. Triangle ABC is similar to, so I'm going 1 angle, 2 angle, right angle. So 1, 2 right angle would be triangle DEF. That's the similarity statement. That was one thing they asked for. Got it. Then find x. Okay, so let's solve for x. So for 2, we're looking at, so I know which sides match with which. So let's set up that proportion. Well, we know 21 is to x. So remember, I'm going from the left triangle to the right. So I can't then go 18 to 27 backwards. I have to go in that same order. Okay, so 27 is to 18. Okay, so those ratios need to be the same. All right, and then we just solve. So so let's clean this up. I could divide both sides by 3, so let's do that. So we get 7 over x equals 9 over 18. Then I could simplify this. It's just a fraction, so that's the same as 1/2. So just simplifying this, I get 7 over x equals 1/2. Now I can cross multiply, and I get 1x equals 14. So x is 14. Okay, and then the third thing, it says find the measures of the indicated sides and the scale factor. So how would we find df here? Oh, df is just x. That's silly. Okay, so df is 14. That was a silly question. And then the last thing is and the scale factor. So the scale factor between these is you match any two corresponding sides. So I already established this order. So the scale factor is this, is the ABCD value to its corresponding DEF value, and then I just reduce it. So divide both by 3, and we get 9 is to 6. I could have divided both by 9. So let's divide both by 3 again, and we get 3 to 2. So the ratio of, and the order matters here, the ratio of triangle ABCD to triangle DEF is 3 to 2. So it's telling us which one is bigger because the order matters. All right, let's do the next one. So it tells us these are similar. All right, and we know by the angle markings which sides go with which. So here's the angle 1 and angle 2 to the angle 1 and angle 2. And I'll use colors to do mine, okay? So angle 2 to angle 3, we'll go to angle 2 to angle 3, which we don't have a value there. And then angle 3 to angle 4 would be right here, and angle 3 to angle 4. And then let's do orange. And so between angle 1 and angle 4, is angle 1 and angle 4. All right, so now let's write the corresponding statement. And this was because we're not proving that they're similar. It told us they're similar. All it wants us to do is write the correct order. So I'm going to do ABCD because that's a nice order. Okay, and ABCD is similar to, so from 1, 2, 3, 4. Oh, that's nice. So 1, 2, 3, 4. That would be, whoopsie. That would be this order. Okay. So let's make sure I'm not going off the page here. That would be E to F to G to H. All right, so the second thing then is they want us to find x. Okay, so we need to set up some ratio here. So this time, I'm going to go backwards just to show you we can. So I'm going to do the bigger one first. So I'm going to say green is to green. So that's x plus 5 is to 14. The reason I knew those lined up was because of the angle markers. Between angle 1 and 2 matches between angle 1 and 2. I use those angle markers, or you could have used letters. For example, now that I have everything labeled with my similarity statement, I could have said EF goes with AB, right? So x plus 5 goes with 14. All right, and then the second one is that's the same, right? Any corresponding value from the right to the left is the same. So it's x minus 3 is to 10. So these two ratios should be the same, and blue to blue and pink to pink, we just don't have those values to compare, but all of those ratios should be the same. All right, so let's go ahead and solve this. Well, we're going to just cross multiply. So that's 10 times x plus 5 equals 14 times x minus 3. So that's 10x plus 50 equals 14x minus 42. And then we subtract the 10x from both sides. We get that's a 4x over here. We add the 42 to both sides, and we get that's 92. And then we divide by 4. We get x is what, 23? That's 40, 80, and yeah, I think so. Okay, so that's x. And then we have to look at what it's asking for part 3. Part 3, it says, find the indicated sides and the scale factor. Okay, so the indicated sides are FE, got it, EH, got it, and GF. Ooh, a totally unknown. That's different. Okay, so EF is an easy one. Okay, EF is just x plus 5, so that's just 28. Okay, the other one's easy too, EH, because that's just x minus 3, so that's just 20. Okay, but we're going to continue 3 up here. Okay, this is 3 continued. To find GF, we got to use another proportion. So we know a side, like let's do orange to orange again. So orange was, EH was 20. So we know 20 is to 10 as GF from the big shape is to its matching pink 16. And then I'm going to simplify this left. 2 over 1, or 2, is equal to GF over 16. I multiply both sides by 16, and I get GF is equal to 32. And what's the scale factor here? Well, the scale factor is just any side to the other, and I just did that right here. That's 20 to 10. So it's a 20 to 10 ratio. But since I set this up as the order of A, B, C, D first, I'm going to pick something from the left and say that's 10 to 20, or a 1 to 2 scale factor, or a 1 to 2 ratio, just because I wrote my similarity statement in that order. Notice I could double check. 16 to 32, yes, that's half. 14 to 28, yes, that's half. So they were all in a 1 to 2 ratio. Ooh, that worked out nicely. Okay, so a rectangle with length 60 centimeters and height 40 centimeters. Okay, so that's easy to draw. We got a 60 and a 40. Is reduced so that the new rectangle is similar. Ooh, okay. But the scale factor is 1 to 4. So 1/4. So that's a little misleading, but okay. So it's reduced so that the scale factor is 4 to 1. The bigger one is in a 4, and the smaller one is in a 1. So another way to think about that is each one of these is 1/4 as long. That's an easy way to think about it, right? Or the way you could think about it is you could call this like h in this width, right? And you could go, ooh, well, 60 is to width as, and then you use the ratio. Well, where does the 4 and the 1 go, right? We've got a 4 and a 1. And it's like, well, which one goes on top and on bottom? So you got to know which one's the bigger one. Well, 60 is the bigger one, so that goes with the 4. And the width over here on the right is the smaller one of the thing we shrunk, so the 1 goes on bottom. Cross multiply, 4W equals 60, and so W equals 15, which is what we would have got down here. 1/5 of 60 is 15, 1/4 of, did I say 1/6? 1/4 of 60, and then 1/4 of 40 is 10. So this is a 10 by 15 rectangle. And then it says find the length and height of the new rectangle. Oh, we did it. Perfect. Okay. Determine whether each pair of figures is similar and justify your answers. Well, let's look. All corresponding angles are congruent. So 60, 120, 130, 50. 60, 120, 130, 150. Oh, yep, there's 4 angles. They all match. So all corresponding angles congruent. Check. Now we just got to go in order and see if the sides match. Well, they tell us 2 markings. That's in order so far. It's between the 60 and the 120. Then this one matches between 120 and 130. This one matches between 130 and 50. And then they share the side, reflexive property. So yeah, all sides, not just, I shouldn't say all sides. It's all corresponding sides. Are they proportional? More than that, they're congruent. Right? And so if they're congruent, yes, they're proportional, and the ratio is 1 to 1. So yes, they are similar, more than similar. They're similar and in a ratio of 1 to 1. And we have a special word for that. It's called congruent. Okay, let's look over at the right then. Justify your answer. Okay, so we got these 2 sides from this triangle match these 2 sides from the other triangle. Oh, that's good. Oh, and look, their base angles are the same. Look at that. Well, what does that tell you? If these 2 angles of one triangle are the same as these two angles of another triangle, well then simple algebra or our third angle theorem, which we'll use a lot in this chapter, third angle theorem, says, well then the last angle must be the same, right? 180 minus the same two angles in one triangle, and then in the other triangle, 180 minus the exact two angles. Of course you're going to get the same number in both. Okay, so if we just clean this up, we've got all three angles match, check. And then in between the 1 and the 2, this matches with in between 1 and 2 this. And then the other triangle between 1 and 2 this matches in between 1 and 2 this. Wow, so we got all the sides except for the last one, except what? They told us it was 10. So again, just like the last one, we use the third angle theorem here to get the last piece. But yes, these are congruent. Congruent triangles. So similar, whoa, that doesn't say similar. Similar with 1-to-1 ratio. Wow, okay. So let's go down to this one. Are these similar? Well, right away. Are the angles the same? No. So the answer is no. Flat out. There's no if and f. There's no if and f. What's that mean? But the thing here is, this is a really common mistake. Conceptually, the big idea here is ratios and proportions all deal with multiplication. You are multiplying by 2 to make it twice as long. You are never adding or subtracting. See what they did here is they subtracted 1 and added 1. Addition and subtraction have nothing to do with ratio and proportions. That's a whole separate conversation, which I would love to get into. But no, let's not right now. But it's really interesting, the difference on how adding 5 to both things, what that does is it actually approaches asymptotically an equilateral shape or a regular shape, because the bigger the sides get, if you keep adding like the same value to all the sides, they just approach whatever difference they used to have. By the time you're up in the millions of side lengths, all the things are about the same. And so really, whatever shape you had, you just approach this regular shape eventually. That's the simple answer, but no. Okay. So, number 14, and the angles are not the same. That's why. Okay, this one. Ooh, again, you have two angles match. So we know the third one matches. That's by third angle theorem. We're going to use that a lot. Third angle theorem. Okay, got it. And then let's check if the sides match. So now we use in between. So between the 1 and the 2, 2 is to 1 and the 2. Ooh, 5 and a third. We're going to have to do some arithmetic here. Woo, got the heebie-jeebies. Okay, between 2 and 3, between 2 and 3, so that's 3 is to 8. Again, or you could just do small with small, medium with medium, but this way is safe that they didn't trick us and like flip sides around in some impossible situation. Okay, and then 4 is between 1 and 3, so between 1 and 3 is to 10 and 2/3. Okay, so here's what we're going to do. We have 3/8 simplified. So what I'm going to do is I'm going to make this bottom here into what do you call it? Improper fraction. So this becomes 16/3, and over here this is 32/3. Okay, so now if you're going to divide by a fraction, that's 2 divided by 16/3. That's the same as 2 times 3/16, and then these cancel, and you get 1 and 8. So okay, that's 1 times 3/8. So this is 3/8. Check. And that's 3/8. Oh, if the last one matches. I'm excited. Okay, let's see. Ready? So this is 4 divided by 3/32. So that's 4 times. You flip it over. 32/3. What? I did that backwards. I apologize. Let's switch that back. Shoo-ba-doo. So we got 4 divided by 32/3. So we flip it over, and it's 4 times 3/32. These cancel, and you're left to a 1 and an 8. And what the heebie-jeebies. Okay, we got 3/8 equals 3/8 equals 3/8. So all three sides are proportional, and all three angles match by the third angle theorem. So yes. Okay, and let's look up here. It just says justifies. So yes, and we show that third angle theorem. So all angles congruent, or all corresponding angles congruent. And then we justified that all three have the same ratio. All right, use the following information. So a picture is enlarged by a scale factor of 4 to 5. So we have this, and then all of a sudden we go, and we multiply all the sides by 5/4. It's a little bigger. And then it says, whoa, it's enlarged again. So we multiply it by 5/4 again, and whoop, it's even bigger. All right. So if the original picture was 2.5 inches by 4 inches, what were the dimensions after both enlargements? So we just multiply by 5/4. Or you set up a proportion, and you go like height and width, and you go 4 is to h as, and then you make sure you get which is bigger and smaller, and you go, and the ratio that it should match is 5 to 4, 4 to 5, and 4 was in the smaller, so it should match 4 to 5. Oh, this was just 5. And then similar, okay? And so on the other one, if we wanted to do it this way, we go, okay, so 2.5 is to width as small is to big, and then you just go cross multiply, so we go 4w equals, and that's what, 10 and 12.5. Okay, and then we divide both by 4. Oof, 12.5 divided by 4. That's, ooh, I can't do that in my head. So that's w equals what, 3 point, because the 12 divided by 4 is 3. What's a half divided by 4? It's an 8, so 0.125. There we go. Okay, so that's what the width is. Now again, we could have just said multiply it, right? So if we had 4 and multiplied it by 5/4, the 4 and the 4 cancel, and we just get 5. And we do it to this too, so we get 3.125. I'm going to split this into fractions. I just like fractions so much more. So we're going to write this in terms of eighths. So this is 3 is 24 eighths plus the 1/8. So this was 25 eighths. And that was because this originally was 5 halves. That's what 2.5 is. And when we multiplied by 5/4, we got 25 on top and eighths on bottom, just to show you. Okay, so now we've got those two dimensions. So multiplying by 5/4 again, we get 5/4, whoa, 5/4 times 5. That's 5 over 1, so that's 25/4 is this dimension. And the other dimension, I'm just going to write it on bottom because I have more room. It was 25 eighths. And I'm multiplying it by 5/4. So it's just 125 over 32. Woo, that would have not been fun with decimals. Okay, write an equation describing both the enlargement process. Okay, I don't know what they're looking for there. Let's start with height times 5/4 times 5/4 equals, I'll call it height small equals height big. There's an equation. An equation just has an equal sign. So I think that's a good way to recognize it. Or we could do both. So the small width times 5/4 times 5/4 equals the big width. That's a good one. Okay, by what scale factor was the original enlarged? So if we were to do both steps at once, what's the ratio? So one way is just to pick a side, this one, and say what ratio is it to this one, right? So let's do big to small because the last one had a 5 over 4, so it was big on top. So let's do the big. 25/4 is the end dimension, and the starting dimension was 4. So what's that ratio? That's the answer. And so let's see, 25/4 divided by 4, which is 4 over 1. That's 25/4 times 1/4, or 25 to 16. That's the end enlargement. Or another way to do it is say, well, I just multiplied by 5/4 and then I did it again. So what's 5/4 times 5/4? That's just 25 on top, 16 on bottom. Woohoo! Okay, so that was the second. 22 is a funky question, but I like that. Oh yeah, sometimes, always, never. All right, so two congruent triangles are similar. Always ratio 1 to 1. Easy peasy. We already talked about that. Two squares are similar. Think about two squares, right? So here's a square. So all the angles are right angles, always. Okay, so all angles match. Check. And then the sides are all 1. And then every other one, I don't care what it is. Let's say 5. All of them are 5. And so what's the ratio of every side to side? 1 to 5, 1 to 5, 1 to 5, 1 to 5. Yep, always. Okay, and then a triangle is similar to a quadrilateral. Never. Similar means they're the same shape. A triangle can never be the same shape as a four-sided thing. That's what? That's a crazy question. Okay, two isosceles triangles are similar. Well, that could be, right? Like here's a 10 and a, whoa, I should have thought about that first. That's 170, 85, and an 85. and a 1 and a, I don't know what, like we'd have to come up with actual lengths. Let's say 3 and 3 and 4. These are not correct lengths because we could use trig to actually find the lengths. But yeah, that'd be similar to, and I just draw the same thing. 10, 85, 85, and we just double it. 6, 6, 8. Woohoo! Right? So yeah, it could be. But I could also do a really funky isosceles triangle like this, like 160, 10, 10, and whatever lengths there. So it doesn't have to be always. So let's say similar. Okay, 2 rectangles are similar. Oh, that was the very question we did for like the second question right here. So come up with a counter example. So we know it's not always. And then we could have just doubled all these, right? So 2, 4, 2, 4 as the lengths. So yeah, it could be, but it doesn't have to be. So that's a sometimes. 2 obtuse triangles are similar. Again, that's going to be sometimes because I could think of one. Oh, here was one right here. I could just do sides of 1. Well, let's do 3, 3, and 4 again. I'm just making numbers up. And then we could double it. 6, 6, 8. So that works. But I could have also done, this was like a 150. Right? So sometimes, yeah. I might land on 2 obtuse triangles that are similar. But the vast majority of obtuse, think about one obtuse triangle with a 50 or with a 130, and then another obtuse triangle with a 140 degree angle. Those aren't similar. So done. It can't be always. And we could just take any triangle and double its lengths and get a similar copy of it. So it's at least there is one. And 2 equilateral triangles are similar. So just like the squares, if you have an equilateral triangle, then you know all the angles are 60, 60, 60. They're all the same. Another equilateral triangle is also going to be 60, 60, 60, but the sides are going to be some other length, like 5, 5, 5. But whatever the ratio of one side is, that's going to be the same as every ratio for every side, so that's always going to be true. So yeah, every single regular polygon, right, whether it's a 3-sided equilateral triangle, a 4-sided regular shape, so that's a square, or a 5-sided regular polygon, there's really only one version of it. And we're just enlarging or shrinking it, right? It's got this universal symmetry. There's no other square. There's one square, and we just make it bigger or smaller every time we make it. Ooh, that's powerful. Okay, we're just going to do a couple more. So I think, yeah, these are the last 4. Okay, so the question here is, they are similar. Write the similarity statement, find x, and all that. Okay, so they tell us the order here, so we can write this right away. So let's see, A, B, C, D. That's in order of angle 1, 2, 3, 4 is similar angle 1, 2, 3, 4, E, F, G, H. And then it says solve for x. So I'm going to go x minus 1. So between the 1 and the 2, matches between the 1 and the 2. Between the 3 and the 4, matches between the 3 and the 4. So I know x plus 1 is to 8, as x minus 1 is to 5. Cross multiply, you get 5 times x plus 1 equals 8 times x minus 1. I was just double checking my work. So 5x plus 5 equals 8x minus 8. So subtracting the x's, we have 3 x's left. Adding the 8, we get 13. So x is 13 thirds. Okay, and then it says find the lengths of AB and CD. Okay, so AB, just plugging it in. 13 thirds plus 1 is 16 thirds because we just add 3 thirds. This one over here is 13 thirds minus 1, so it's 10 thirds. And then we just need to find the ratio. So what's the ratio of 16 thirds to 8? Because again, I'm going to do the A, B, C, D first. So 16 thirds to 8. I can multiply both sides by 3. And I get 16 to 24. Whoops, 2 dots. And I could divide both sides by 8. And I get 2 to 3. Okay, and I could just double check with the other one whether that works. So 10 thirds is to 5. So again, I'd multiply both sides by 3. So I get 10 is to 15. Dividing by 5, I get 2 is to 3. Yeah, so I got the same ratio on both of them just to double check my work. All right, so over here, they only seem to give you a right angle, and you're like, well, what the heck? What matches with what? Well, here's one thing. Because of those right angles, those are alternate interior angles that are congruent, so you know these lines are parallel, which means alternate interior angles are congruent, and you know vertical angles are congruent, so we actually do know the order. So the order has to be let's see, I'll just do ABC because that's a great order to start with, is similar to, it's a triangle, is similar to triangle, so 1 to right angle to 2. So 1 right angle 2 would be EDC. That order has to be the same. Okay, and now we could set up some proportions. So let's see, we know, I'm going to start with the x's on top. So EC is 2, so I'm going from this triangle to this triangle. So EC, 12 minus x, is 2. And now what in the left triangle would be AC. Okay, that's x plus 7. And that's equal to, oh yeah, hypotenuse to right triangle to hypotenuse to right triangle. And then over here, let's use angle marking. So between the right angle and 2 is to between right angle and 2. So again, I have to match. So I'm doing the triangle EDC on top. So that's the 6 is to 4. Okay, so I set up my proportion. Now, I was showing you that you could either use this statement and just go by the letters that way, or you could use the picture and go by angle markings here. Either way, as long as you go from one triangle to the other, you are set. Just don't flip-flop. Okay, so let's cross multiply and solve. So we get 4 times 12 minus x equals 6 times x plus 7. That's 48 minus 4x equals 6x plus, that's a 7, I'm so sloppy, plus 42. Let's add the 4x to both sides. Let's subtract the 42 from both sides. And we get 10x equals, just double checking my work, 6. So we get x equals 6/10 or x equals 3/5. Okay, so we got x. I don't know why I started writing so small there. So we have a similarity statement. We have x. We need to find these sides. So plugging it in, I'm going to make some room here. Okay, so plugging in 3/5, that's 3/5 plus 35/5. So that's 38/5. And then over here in the other triangle, we have 12 minus 3/5. So that's in terms of fifths, that's 60/5 minus 3/5, or 57/5. Okay, so now we're just going to do the ratio. The ratio here is 6 to 4. Man, did I do a mistake here? We'll check and see if it works out in the end. So I could just pick the easiest numbers here. So from ABCD to EDC, that would be the 4 to the 6. So we have a ratio of 4 to 6 or 2 to 3. Okay, that's our scale factor between the two in order matching this statement. All right, so now the question is, did we make a little mistake here? Let's check this out. So we should have then that 38, the smaller, yeah, so 38/5 is to 57/5 as 4 is to 6 or 2 is to 3. Well, this is 2 over 3. We know this is 2 over 3, so we can just erase that. That's what we're looking for. All right, so let's rewrite this then. We have 38/5 divided by 57/5, and then we go, that's 38/5 times 5 over 57, cancel, 1, 1. And you might be like, well, that's crazy. Well, guess what? There's a 19 here and a 19 here. This is 2 19s, and this is 3 19s. So holy moly, we get 2 to 3. It checked out. I just like double checking my work at the end. You can always double check your work. Okay, so in this one, this is the only one I didn't like, 19. So I wanted to put it in here. We'll come back to it. Let's go over the other problem. All right, so we got a 27 and a 27 and a 1/10. So that means this last angle is a 43 just by algebra. So this one matches this one, okay? So we know that it's triangle RST is similar to triangle from 1 to 2, so RST, so EGF. All right, and then we need to just solve for missing sides, so that's just a straight proportion with an x. So that's, I'm going to do it different. Instead of going triangle to triangle, I'm going to go corresponding sides this time. So I'm going to say 10 is to 15. So I'm picking two sides here. So 10 is to 15 as, and then I'm going to set up that same ratio in the other triangle. So between the 110 and 43, I start, so that's x. And then I end between the 27 and the 110, so that's 11.25. Okay, so now I'm just going to simplify this on the right, so that's 2 equals x over 11.25. So multiplying by that on both sides, and I get x is equal to, off to the side here, 22.5. Okay, great. So that's 22.5. Then the question is, what's GF? Well, that's 22.5. What's EG? Well, what the heck? It's totally blank. Well, that's when we use ratios and proportions, right? So we say, okay, well, I'm going to use two sides that I know. So let's say 10 is to, I'll do it, ooh, we don't have a lot of room. So 10 is to 22.5. That's, this side is to this side, as RS is to this side. So that means 10 is to 22.5 as 20.7 is to, and then I'm going to call this y. I don't know this side length. So cross multiplying, I get 10y equals whatever this is. I'm just going to leave that junk for your calculator. And then we just divide both sides by 10. And we get y equals that hot mess. Okay, that's for a calculator. Now the question is, what's the scale factor? Well, the scale factor here is, let's pick some sides. So we're going in the same order as our similarity statement. So it's 10, or it's 15, and I'm just going to write this in terms of fractions. So that's 11.25. So that's 44 fourths plus 1/4. So that's 45 fourths on bottom. And so 15 divided by, divided by 45 fourths is the same as 15 over 1 times 4 over 45. And then we just cancel these and we go, well, 15 goes into both, 1 time here, 3 times here, and we get a 4 to 3 ratio. So this is a 4 to 3 scale factor. And you could always double check that by plugging that back in. Okay, so let's go over to the left. The only reason I don't like this one is, you know, it shares this angle. The small triangle and the big triangle both have this angle. But without knowing another piece of information, I don't like that you have to just assume which angles. Now you could say, well, this side is longer than this side, because it could look like this. Like it could go this way and then this way, where the smaller triangle is actually similar to the bigger triangle, but you flip around. So you take this triangle and flip it like mirror image to be similar to the big one. That could be the case. But you could argue, well, like that's impossible, because no matter what number you choose, that number minus 1 is always smaller than that number plus 2. Because you're literally on a number line saying, start here and go more, greater than by 2, and go less than by 1. So you could say this is always going to be bigger than this, so we know, but they should have told us which angles correspond. But what you end up getting is these two angles correspond, and then that means these lines are parallel, and these angles match, and so that's the order they wanted. They didn't really give us enough. So that was a little bit sloppy on their part. So then we know that triangle AEB is similar to triangle ADC. Okay, that's our similarity statement. And then we could even start looking at some proportions. And this is throwing you kind of like a curveball question here. And so we know that the sides of these shapes are proportional. So what we know is that 10, like the side of this triangle 10. So I'm gonna actually write this. So here's one that's 10, 6.25, 1, 2, 3. But here's the actual triangle that we have it similar to. And this is going to be a big one in the next section, or the one after, when we talk about the triangle proportionality theorem, however that one goes. When we talk about that, we'll notice that this is actually, what's the side of this triangle here? Well, the side is, you actually add those two segments together. So actually this is x plus 2 plus 10. And what's the side on the right? It's actually x minus 1 plus 6.25. So actually the ratios we can set up is 10 is to x plus 2 plus 10, as 6.25 is to x minus 1 plus 5.25, plus 6.25. So that's the actual ratio that we have. If we want to solve for x and we want to solve for these missing sides, we can't use a portion of a side. We don't have any ability right now to say a portion of a side is anything. All we know is the entire side is proportional. So here we go, down here. This is 10 over x plus 12 equals 6.25 over x plus 5.25. Then we cross multiply, so we get 10 times x plus 5.25. So that's 10x plus 52.5 equals, and then we get 6.25, distributing it in, 6.25 times x plus 12. And so we get that 6.25x plus, what was this? This was 6 1/4 or 25/4 times 12. So that's cancel, you get 3 and 1. So that's 75. Okay. And so now subtracting on the left, we get 3.75x equals, and on the right, we get 22.5. Whoo-wee! I'm going to multiply both sides by 4, so I don't have to deal with this anymore. So this was 3 3/4, so that's 12 quarters and 3/4, or 15 quarters x. And on the right, this was 45 halves. So if I multiply both sides by 4, I get 15x equals 90. Oh, that's a lot nicer. And then we just divide both sides by 15, and we get x is 6. Okay, so x is 6. We go back up here. That means this side was 5, and this side was 7. And so the last thing here is just saying the size from AEB to ADC. You just pick any side. So I'm going to say this side over here between 1 and 3, between 1 and 3. So we get the ratio is 10 to 17. Or you could do it over here and you say, oh, okay, so those two match. So I'm going to say it's 6.25 to the total, and then you add them together and you get to 11.25. And now if I multiply this by 4 on both sides, I get 45, and on the left I get, what is that, 25? Trying to do that math in my head. I get 25. And so you could simplify this and just see that you get the exact same ratio. So 4 times that 25, you divide both sides by 5, and you get 5 is to 9. And why didn't I get, oh, look at this. It was 6 plus 2, not 6 plus 1. This was an 8. See? Double checking my work, and it helped me. So this was 10 to 18, or 5 to 9. So double checking helped. We get a 5 to 9. All right, you guys, hope you enjoyed the video.